my e-learning module of linear programming problem presented by Mr. A.P. Tripathi, PGT Maths of JNB Muradabad, Lucknow region, and Mr. Vikram Singh Rawat, JNB Nahan, Himachal Pradesh.
I welcome you all in the presentation presented by Analyte Goa. Today we will throw light on the linear programming. At present it becomes a strong tool for the success of any project. Linear programming came in the existence during Second World War for the transportation problem, and now it becomes very strong tool in every field. Everyone is using linear programming in one hand or the other hand. Doctors are using it for the diet problem, for the diets, and the engineers are using for planning. Architects are using for the new design, and the industrialists are using it for the new industry, for the maximum profit. With the help of linear programming, we can find the optimal value, that is the maximum profit with minimum cost. And with the help of this tool, we can manage the business financials using this tool very frequently. And today, in today's scenario, it becomes a very strong tool. And
linear programming problem came to the forefront during Second World War. The first problem in the linear equation was formulated in 1941 by Russian mathematician L. Kontosovich and the American economist F.L. Hitchcock. This was a transportation problem. In 1945, an English economist G. Stigler formulated an optimal diet problem. L. Kontosovich and T.C. Kummermans were awarded the Nobel Prize in the year 1975 in economics for their work in the linear programming.
In my e-learning module of linear programming problem, linear programming problem is one that is concerned with finding the optimal, maximum or minimum value of an objective function. That is the linear function of several variables like x and y, subject to the condition that the variables are non-negative and satisfy linear constraints, a set of linear inequalities. The term linear implies that all the mathematical relations used in the problem of linear relations. The term programming implies that method of determining a particular program or plane of action.
Linear programming problem is one that is concerned with finding the optimal, maximum or minimum value of an objective function, that is linear function, of several variables like x and y, subject to the conditions that the variables are non-negative and satisfy linear constants, a set of linear inequalities. The term linear implies that all the mathematical relations used in the problem are linear relations. The term programming implies that method of determining a particular program or plan of action.
Objective function, a linear function z equal to ax plus by, which has to be maximized or minimized, is called a linear objective function, where a and b are constants. Next is decision variable. Variables x and y are known as decision variable. Third one is constants. The linear inequalities or equations or restrictions on the variables of a linear programming problem are known as constants or overriding conditions. The conditions x greater than or equal to 0, y greater than or equal to 0 are called non-negative constants.
Optimization problems. A problem which needs to maximize or minimize a linear function subject to certain constants as determined by a set of linear inequalities is called an optimization problem. Linear programming problems are a special type of optimization problems.
Graphical method of solving linear programming problems. The region here shown in the graph, the region OABC is feasible region. Every point with and on the boundary of the feasible region OABC represents the feasible solution.
Examples. A bakery house makes two types of cakes, brand A and brand B. One piece of brand A cakes require 200 gram of flour and 25 gram of fat, while one piece of brand B cake requires 100 gram of flour and 50 gram of fat. In bakery house, 5 kg of flour and 1 kg of fat is available. Find the maximum pieces of cakes which can be made from the available flour and fat in the bakery house.
This is a linear programming problem. Let us assume that X pieces of brand A cakes and Y pieces of brand B cakes are made in the bakery house. Here X and Y are known as decision variables. Now maximum number of cakes made is to be calculated. Let us suppose that Z equal to XY is linear objective function. The number pieces of cakes X and Y are greater than or equal to 0 are called non-negative constant.
Amount of fat needed to make one piece of brand A cake equal to 25 gram. Amount of fat needed to make X piece of brand A cake equal to 25 x gram. Amount of fat needed to make one piece of brand B cake equal to 50 gram. Amount of fat needed to make Y piece of brand B cake equal to 50 Y gram. Amount of fat needed to make X piece of brand A cake and Y piece of brand B cake equal to 25x plus 50y. So therefore amount of fat available in bakery house equal to 1 kg, that is 1000 gram. So therefore 25x plus 50y less than equal to 1000, that is x plus 2y less than equal to 40. This is constant number 2. Graphical method of solving linear equation. So after drawing the constants, the corresponding equations are x equal to 0, y equal to 0, x plus 2y equal to 40 and 2x plus y equal to 50. After drawing these equations, the region OABC obtained is feasible region, and always maximum value or minimum value or optimum values lies on the corner points. So therefore OABC are corner points. So these points will give the maximum, minimum or optimum value.
Now from the graph it is clear that corner points of the feasible region are O 0, 0, A 25, 0, B 20, 10 and C 0, 20. These can be writing in the tabular form. Here corner points are given and their corresponding values of Z equal to XY is also given. From the table it is clear that maximum values of Z is 30 at point B 20, 10. Hence the optimum solution is 30 at the point B, that is 20, 10. So the 20 pieces of brand A cakes and 10 pieces of brand B cakes are to be made in bakery house for as per given requirement. So many real life examples can be solved by linear programming problems. In this case, transportation problem is given on this context.
Transportation problem like how should the supplies be transported in order to get the transportation cost is minimum. What is the minimum cost? This is all about presentation. If you have any query, please feel free to contact us through mail or by mobile. Our Gmail addresses are ayodhyatripathi@gmail.com and mobile number 9756546813, and myself Vikram Singh Rawat, and my address is vikrammini2004@gmail.com and the mobile number 9417505958.